Welcome to this lesson on wave behavior. In this session, we will define the fundamental nature of waves, examine how they interact with different media, and explore the core behaviors of reflection, refraction, and diffraction, all without going into mathematical details. Hello everyone, and welcome back to our physics series. Before we dive into behavior, let's recall that waves are categorized as mechanical or electromagnetic and can travel through longitudinal or transverse motion. Today, we focus on how these waves encounter and interact with boundaries. At its core, a wave is a disturbance that transfers energy through a medium without transferring matter. Think of it as energy in motion, where the particles of the medium oscillate vertically, as seen in this transverse wave, but return to their equilibrium position as the crests move horizontally from left to right. When a wave moves from one medium to another, properties like frequency remain constant, but speed and wavelength change. As we see here, a water wave moving from a deeper to a shallower region decreases the speed and visibly shortens the wavelength, a relationship governed by the universal wave equation. But what happens when a wave hits a wall or an obstacle? There are three main outcomes. The wave can bounce back, be soaked up by the material, or pass right through it into a new space. Reflection occurs when a wave hits a boundary and bounces back. It follows the law of reflection, where the angle of incidence equals the angle of reflection. Crucially, as we see in this plane, the incident ray, reflected ray, and normal all lie in the same geometric plane. Absorption happens when the medium takes in the wave's energy, while transmission is when the wave successfully enters and travels through the material. Materials can be classified based on how they transmit waves. Opaque materials block transmission, transparent materials allow waves to pass through clearly, and translucent materials scatter the waves as they pass through. We also see more complex behaviors like refraction, where waves bend as they change speed entering a new medium. In water, the waves slow down and bend inwards toward the normal. And diffraction, where waves spread out after passing through a small opening or around a corner. Before we conclude, let's clear up some common misconceptions. Remember, waves transfer energy, not matter, and while speed and wavelength change between media, the frequency is always set by the source and remains constant. Understanding these behaviors allows us to manipulate waves for technology, from high-speed fiber optics to high-precision lenses. I hope this overview has clarified the dynamic nature of wave interactions and how they shape our world. You can find related videos on our channel to see what happens when two waves meet in the same space. See you then!